Call a fraction a over b not necessarily in the simplest form special if a and b are positive integers whose sum is 15. How many distinct integers can be written as a sum of two not necessarily different special fractions? Let's first write out these special fractions. We have 1 over 14, 2 over 13, 3 over 12, 4 over 11, 5 over 10, 6 over 9, 7 over 8, 8 over 7, 9 over 6, 10 over 5, 11 over 4, 12 over 3, 13 over 2, and 14 over 1. So let's first work on trying to simplify these into their simplest forms. They become 1 over 14, 2 over 13, 1/4, 4 over 11, 1/2, 2/3, 7/8, 8/7, 3/2, 2, 11 over 4, 4, 13 over 2, and 14. First off, we notice that for two numbers to sum up to an integer, their denominators have to be the same number or to have any chance of summing up to an integer. So in order for that to happen, we can take out numbers whose denominators don't appear twice in this series over here, or the sequence of numbers. So we have 13, 14 are out, 11, 3, 8, and 7. And everything else, right? 4 appears twice, 2 appears more than twice as a denominator, and then we have integers. So let's take this into three cases. Case 1 is when we use all the integers 2, 4, and 14. Case 2 is when we use the numbers with denominator 2, which are 1/2, 3/2, and 13 over 2. And then we ultimately have the numbers with denominator 4, and these turn out to be 1 over 4 and 11 over 4. So let's look at the respective sums from each of these cases. While each number can first sum to itself in the first case, so that becomes 4, 8, 28 as possible sums. And then we have 2 plus 4, which is 6, 2 plus 14 is 16, and 4 plus 14 is 18. Now let's look at case 2. Every number can be added to itself, right? So 1/2 plus 1/2 is 1, 3, and then 13. 1/2 plus 3/2 is 2. 1/2 plus 13 over 2 gives us 7. And 3/2 plus 13 over 2 gives us 8. Okay, and then ultimately on to our third case. We have that 11 over 4 plus 1 over 4 will be able to give us 3. 1/4 plus 1/4 gives us a fraction. 11 over 4 plus 11 over 4 gives us a fraction as well. So now we have a certain number of distinct answers. Well, 4, 8, 28, 6, 16, 18. 1, 3, 13, 2, 7, 8 is already said in the first case, and 3 is already called for in the second case as well. So now we just add up, there's 6 from here, 5 from here, so that adds up to a total of 11 distinct integers that can be written as a sum of two, not necessarily different special fractions. And that is answer choice C.